Ever wondered what does the future of guitar repair look like? Well, we can try to guess, or we can take a more scientific approach and look into the future. Well, to me, it kind of looks upside down. So why don't you watch this video till the end? Because I'm about to take you into the future. There's an old Chinese proverb that says, the future ain't what it used to be. And if I can keep your attention for the next 20 or 30 minutes, I'll show you what I mean. Now, I'm strictly talking about the future of guitar quackery, and perhaps even the future of guitar services as a whole. Now, if you watch Guitar Quackery, you know that Guitar Quackery is known for guitar microscopy. And we'll continue doing that. But I also decided to explore something new. So I branched off into a new direction. And it's very exciting. So what is it? 3D scanning. So welcome back to Guitar Quackery. Now let's just do some 3D scanning and then let's see what we can do with it. I just prepped the guitar for 3D scanning. As you can see, I put these stickers all over the guitar. You can see the same stickers here on the two side rails. The reason why I use these two side rails is just so that I don't need to put stickers all over the fingerboard. These stickers are tracking markers that the 3D scanner uses to track the 3D scan as it's scanning it, and also to be able to properly position all of the pixels of the 3D scan in the global coordinate system in the software. This is the 3D scanner. It uses blue laser. Blue has a short wavelength, so it can capture high resolution images. I can monitor my progress right there on the screen. I can show you. As you can see, as soon as I point the scanner on the guitar, it projects these blue laser lines, and that's mirrored right there on the screen. So when I press the scan button, you can see that it starts capturing the image. At first, the image appears pink, but then if you hover over the same area, it turns green. Green means that it's a complete scan. It's not a bad idea to do a preliminary scan of the entire guitar first, and then do a few additional passes of the same areas. This way I can check my exposures, and I can also see if the tracking works. If I lose tracking, it can recover, but if it keeps bumping it off, it might be a good idea to put more markers. As you can see, the strings actually project shadows on the fingerboard. And that's unavoidable, but I can minimize the shadows if I just tilt the scanner in both directions. This way it projects the light onto the strings, and I'm able to minimize the shadows. The reason why I am scanning with the strings on is because for the purposes of this scan, I want to study the neck relief and the soundboard deflection of the guitar. And that can only properly be done if I have the strings on at full tension. Now, I'm just continuing to scan the guitar like this, just moving back over the fingerboard. I can project the light here to capture this part of the bridge, and just keep moving. That area is still pink. Here, it tells me if I'm too close or too far from the object that I'm scanning. as you can see, it's also scanning the surrounding area. This will be later cleaned up in the software before rendering. I'm also going to remove the strings from the scan in the software as much as I can, so that I can have a clear view of the fingerboard. I'm actually almost done scanning. We have one more area left that's pink right here in the lower bout of the guitar. So I want to spend a little time there. It's perfectly fine if it doesn't all turn completely green. We can still use the scan. I actually scanned quite a few guitars lately because I was doing rehumidification services, and I have some before and after scans of guitars that were dried up and then that I rehumidified. I'm going to make separate videos about those. And here, now you can see that we're basically done with the scan. So I am going to stop scanning, just push the button here. And now we see the image here. I can rotate this image in the software like this and analyze it. And if I want to, I can keep scanning. But I think we have a good image. And now I am simply going to clean it up in the software. So I'll show you how this is done. Here, first I push this button here, click yes, and it takes a few seconds to process this. Once it's processed, it turns blue, like this. If I rotate the image, you can look at it also from underneath. The bottom looks orange. And now we want to, we can also zoom in, obviously. We want to position the scan in such direction that I can easily select the part of the workbench with the selection tool like this. And now this will turn red. And I can rotate it to show you. And now this area can simply be deleted like this. And now I can zoom in. And I can also remove the side rails from here. I can remove them in segments, trying not to disturb the scan of the guitar, like that. And I can also rotate the guitar, reposition it, rotate, and zoom in to start removing the strings. I will do all this in off camera, and I will process the image, and then I will show you what the scan looks like and how we can use it to analyze the guitar and to make a full assessment of the guitar. The 3D scanner I just used was a high-end consumer-grade scanner, but since we can obviously use it in a professional environment, we like to categorize it as prosumer grade. The actual model is Creality Raptor Pro Scanner. It can scan up to 20 microns in resolution, but I was using it at a lower resolution for this scan, so I was scanning at 200 microns. Once I clean up the image, it looks like this. As you can see, we can rotate it in space. It's blue on the top, and it looks orange on the back. We can zoom in, and we can study the image. We can look at it. Right now, this image is actually not very useful, but with some additional processing, we can actually do some very interesting things with it, which I'm going to show you. But before I do, I would like to talk about another category of 3D scanners. So like I said, this one is categorized as prosumer grade, but there's another separate category of equipment, industrial grade equipment. So now I want to show you what we could do at a guitar shop with an industrial grade 3D scanner. This is a high resolution scan of a fretboard. This was scanned at 17 microns resolution. So the lower the number, the higher the resolution. This happens to be from an Epiphone Casino guitar. As you can see, this was scanned with the strings on, which is why we see these shadows on the fingerboard. Obviously, we can scan it without the strings on, but in this case, we wanted to use 3D scan to take measurements of the neck relief, which should always be done with strings at full tension. We can also look at the black and white rendition of the scan, which makes it easier to see some details. Back to color. Color shows elevations, so at its lowest point you see blue, then it goes through green, yellow, orange, and red, and then purple shows the highest point in elevation. The scanner used in this case was a line scanner. So a line scanner will scan a whole bunch of lines. The lines are then assembled together into a final image, and the lines are made out of pixels, which are called points. And this is why we call this type of 3D scan a point cloud. So we can zoom in all the way. Now zooming out, we can convert a point cloud into a mesh. And now it looks like this, and it's opaque, so we can no longer see through because there are no open spaces between the points. Back to the point cloud. We can completely flip the image and look at the underside. And because we're looking at a point cloud, we see through because we're seeing through the open spaces. So we see through the fingerboard and we still see the strings, because once again we see through the open spaces. This is how far we can zoom in. So obviously we take a scan like this to take measurements and analyze the subject, in this case, the fingerboard. So far, we've looked at a couple of fancy 3D scans of guitar parts, one captured by a prosumer scanner and one captured by an industrial scanner. But so far, we haven't seen any useful applications for those scans yet. But that's about to change because I'm about to show you. And first, we'll explore some of the possibilities using the industrial scanner. So we can definitely measure things. What could we measure? Well, we could measure everything we would normally be able to measure using conventional methods. So one thing we like to measure on a guitar is, for example, the neck relief. To take an accurate measurement of the neck relief, we can create a virtual cross-section slicing through the fingerboard. We can see it right there. If we look at the black and white rendition of the scan, it makes it easier to see. It's slicing right there through the frets. Now we can switch the profile view and we can see all the frets. Then we can mark off the position of the first fret, the position of the last fret, and the position of the middle fret. Next, we can create a virtual straight edge from the top of the first fret to the top of the last fret. If we zoom in on the middle fret, we can see that there is a small gap between the top of the middle fret and the virtual straight edge. And now we can simply take a measurement and we can see that it is 21/1000ths of an inch. We can also switch to metric, in which case it reads 0.5 millimeters. Before I show you more, let's first hear from our sponsors. Oh, yeah, that's what I thought. There are no sponsors. Guitar Quackery is self-sponsored. I basically buy all the equipment and everything I need to make these videos for you. And you're welcome to watch them. But if you feel like you want to pitch in a little bit, you can click some of the buttons below. There's a super thanks button. There's a button to buy me a coffee. There's a link to buy Guitar Quackery merch. And there's also a Patreon link. So whatever you feel like clicking on, go right ahead. And any money you send my way will be used to further this channel so that I can make more videos for you. Okay, so if you feel like it, feel free. If you don't, we're still friends. It's fine. Just keep watching because I'm about to show you something even more interesting. Now let's use the 3D scan to take a measurement of the fretboard radius. With our 3D scan, we can take a very accurate radius measurement. We can measure the radius of any one of the frets, the radius of the fingerboard, or even the radius of the strings. All we need to do is create a virtual slice through the fingerboard. Right here, we see that it's slicing through one of the frets. Now, this happens to be the 6th fret, but obviously it could be any one of the frets. Once again, if we look at a black and white rendition of the scan, it is just easier to see. Now, if we switch to our profile view of this slice, it shows up like this. And here we can see that the measurement shows up as invalid. And that's because this bounding box is outside of our cross section. But if we move it here, you will see it will automatically draw a blue line, which is actually a circle, and it will tell us that the radius is 11 inches and change. Now this blue line is basically just a circle that the software automatically drew, and we're measuring this radius, which is represented with this yellow arrow. Now we can move the bounding box over to the strings, and you will see it automatically draws a blue line across the strings. And now it tells us that this radius is actually closer to 12 inches, which obviously does not match the radius of our fret. Once again, this is just a circle that it drew. Now we can take a radius measurement of the fingerboard. So this cross section now is showing the fret. But if we go to here, we are now in our 2D view. So in our 2D view, it makes it easier to move this cross section. So now I'm going to move it down here. And now we are, in fact, slicing through the fingerboard. We're no longer slicing through the fret. And if we go back to our profile view, and now we move our bounding box here, we are going to take a measurement of the fingerboard, which is 12 inches and change. And once again, the fingerboard radius does not match the fret radius in our case. Not surprisingly, the industrial grade scanner can scan at higher resolutions than even the high-end consumer grade scanner. It's actually a range of values, and it depends on a few factors, including the distance from the scanner to the workpiece. So there is a minimum and maximum range at which the scanner can be set up from the workpiece. And the closer it is set up within that range, it will scan at a higher resolution. So now I'll show you how a high resolution scan of the fretboard can be used to take microscopic measurements from the frets, including the fret wear, so that we can determine what the outcome of a fret job might be like. And in this case, we are going to study the possible outcome of a level crown and polish. Once we scan our fingerboard, we can look for fret wear on the actual guitar, and then we can easily identify those frets on our 3D scan. Then we can cut a cross section through that part of the fingerboard. It's always easier to see if we look at the black and white image. In our profile view, we can see the cross section of those two frets. And immediately we see that this fret has a little bit more fret wear than this one. So we want to zoom in on this fret so that we can analyze it and take some measurements. So here are two feature boxes. This feature box marks off the highest point on the fret, and this feature box marks off the highest point on the fretboard. And the distance between the two is 1.097 millimeters. Next, we want to know the distance between the fretboard and the bottom of the dimple. So to take this measurement, we want to focus our feature box closer to this area, and then switch from maximum height to minimum height, which is right here. And now we can see that the distance between the top of the fingerboard and the bottom of the dimple is about 1 millimeter, which means that after a level crown and polish, the fret height will probably be a little bit less than 1 millimeter. There are many more possibilities here. I'm just showing you the proof of concept. And as I'm sure you realize by now, we can also archive our scans. So we can take a before and after scan, and this way we have a complete high resolution archive of our work. We can always go back to the old scans, even when we don't have the guitar in front of us, and we can study and measure any part of the scan. So even if we do any kind of work on the guitar and we have a scan of what the guitar was like when we gave it back to the customer, if or when the customer comes back with a problem, we can go back to the previous scan and we can see what changed and then deal with it. So now let's go back to our the first scan that we made using the Creality Raptor Pro scanner. As I said, we can process that image, and when the image is processed, we can do some interesting things with it. So here it is. Again, this is the image in 3D space, and now you can see some colors. So here in the back, you can see red, and here you can see blue. So these colors show elevation. Blue shows the lowest point on the soundboard, and red shows the highest point. We can adjust these colors, so we can add some more blue like this, and we can add some more red, and you can see how it's spreading. And we can study the topography of the soundboard. Now we can also adjust this gray level, and as you can see here, behind the bridge, this is now highlighting the highest point of elevation on this soundboard. And we can continue to, we can increase the amount of it. And now it's highlighting the other parts of the soundboard that are the highest. And if we continue, we can see that another spot shows up right there. And as you can see, we can spread it out like that. And we can pretty much see from this scan that this soundboard is completely warped. And then we do whatever services need to be done. Or we can explain to the customer why the guitar is buzzing or whatever, right? Another useful application for the 3D scans is planning to do a modification project on the guitar. So here I'm going to show you a scan that I made of a current project and how I'm going to plan out everything in 3D space before I do anything to the guitar. This is an interesting project. It's a 3D scan of a Jericho guitar. As you can see, we have all this open space here. And that's because this guitar used to have an Evertune bridge system. But the customer wants to put a Floyd Rose instead. So I removed the Evertune and then I scanned the entire guitar. And I also did a separate 3D scan of a Floyd Rose bridge assembly. So now we can go back to this and we can put a Floyd Rose bridge on this 3D scan. And here they are together. And we can see how it all fits together. Now, as you know, a Floyd Rose bridge requires 2 bridge posts. So here they are. Here is the post on the treble side, and here is the post on the bass side. So this is how they fit together. Now we can flip it, and we can see that we have some missing material. So the 2 posts are not well anchored into the body because we're missing some wood. So now I can use this 3D scan to take some internal measurements of this cavity and design this insert piece. And this is a piece that I can fabricate separately. This is what it looks like. And if I remove the posts and I remove the Floyd Rose system, we can study this piece separately. We can make a 3D print of it, or we can simply print it on paper and then with the measurements and then fabricate it. I'm going to make this piece out of wood. And now in this 3D space, we can also look at the cross section of the guitar so that we see exactly how it fits together. And obviously we can add the 2 bridge posts and we can add the Floyd Rose system. And that's our project. So I'll be using 3D scans in the future for many interesting projects and also upcoming reviews of guitars and perhaps even other gear. Make sure you tell your friends about Guitar Quackery. So post links to this channel on all of the guitar forums. Again, if you want to support this work financially, you can click on some of the links. There's a super thanks. There's a link to buy me a coffee. You can buy Guitar Quackery merch, and you can also support this work on Patreon. Make sure you're subscribed. Also check out the other channel, Guitar Quackery Live. That's the live streaming channel. So I don't do any live streaming on this channel, but I do only live streaming on Guitar Quackery Live if you want to catch me in real time at work. And thank you for watching, and I'll see you soon.